Welcome student in our YouTube channel Physics by TC Chauhan sir. Today we are going to discuss about the application of Gauss Theorem, in which we are going to find electric field intensity due to a spherical shell or hollow sphere. Suppose there is a spherical shell whose radius is capital R and charge given to it is Q. Then there will be electric field around it. This electric field will be outward, normal and radial. This will be the electric field. We have to find electric field intensity due to it. Its surface charge density is sigma is equal to Q upon 4 pi capital R square. Capital R is the radius of the sphere. Now, if we have to find Q, then sigma into 4 pi R square will be there. Now, how to find electric field intensity due to it? There are several cases. First case is outside. Outside means small r greater than capital R. How to find? This is a sphere. Its radius is capital R. Its charge is capital Q, small q. We have to find electric field intensity at this point outside. For this purpose, we draw a Gaussian surface, spherical Gaussian surface. Its electric field is found to be E vector, area vector is found to be A vector. Both are in same direction, so theta will be 0 here. Then by using Gauss theorem, integration E vector dot dA vector is equal to sigma q upon epsilon naught. When dot product is removed, there will be E dA cos 0 degree will be there because angle between them is 0, is equal to sigma q is q upon epsilon. Total charge present is q. Then E integration dA is equal to q upon epsilon naught. E integration dA is the elementary area present on the Gaussian surface. Then total area of the Gaussian spherical surface will be whole area of a sphere, and that is 4 pi small r square is equal to q upon epsilon naught. Then E will be equal to 1 upon 4 pi epsilon naught q upon r square. This is electric field intensity outside. Now, in terms of sigma, it can be represented. You can put the value of Q in terms of sigma. That will be sigma into 4 pi capital R square upon 4 pi epsilon naught small r square. It will get cancelled. Then sigma capital R square upon epsilon naught small r square. This is for vacuum. Epsilon naught is there. This is electric field intensity outside. In the case of medium, there will be epsilon or epsilon not epsilon r, you can write, dielectric constant you can write. So this is outside. Now what about on the surface? On the surface, students, remember, on the surface small r will be equal to capital R, because this observation point will come here on the surface. Then this small r will be equal to capital R, this small r will equal to capital R. In this case, the electric field intensity on the surface will be 1 upon 4 pi epsilon q upon capital R square only. In place of small r, you have to put capital R. That's all. Or you can write it in terms of sigma. E surface is equal to sigma into 4 pi capital R square upon 4 pi epsilon naught capital R square. This will get cancelled. 4 pi will get cancelled. You will have answer E surface is equal to sigma upon epsilon naught. This is electric field intensity on the surface. Now, what about inside? Third is inside. Inside means small r less than capital R. In this case, there is no charge present inside because it is hollow. In the case of hollow, there is no place to reside charge. That means inside there is no charge. It means sigma q is 0 inside. Then flux will be 0. Then electric field intensity will be 0 inside. Now, what about at center? At center, it will be small r is equal to 0. So E center will be 0 because center is lying inside, and at every place inside electric field is 0. That's why it will be 0. Now what about the graph? Graph between E and R. If you have to draw graph between electric field intensity and distance from center, then it will be like this. Remember, inside there is no electric field, so there is no graph formed. Only outside graph will be formed like this. This is all about the graphical representation of electric field intensity versus distance from center. Remember, from center. So inside there is no curve, there is no place to curve because electric field is zero. Outside there is hyperbolic curve because outside electric field is inversely proportional to square of distance. Inside it is zero. It is maximum on the surface. Remember, it is maximum on the surface. On this basis, the question can be asked. There are basically four formulas obtained. E outside, that is kq upon small r square. E on the surface, that is kq upon capital R square. E inside will be 0. E center will be 0. On these parts, question can be asked. I think this session become very useful for you. Please do subscribe, share and like our YouTube channel, Physics by DC Chauhan. Thank you very much.